convex mirror has a focal length of 3 meters, and we place an object 4 meters in front of the mirror. We want to find the location of the image, this time using the lens maker's equation. Now in the previous example, I showed you guys how to do it with the ray diagrams, and this was kind of the screenshot of what ended up happening. So a convex mirror is silvered on the left and solid on the right. So this side is the silvered side. Now, a convex mirror happens to have a virtual focal point. The rays of light only appear to converge at the 3 meter mark. They don't actually slam off the mirror and go passing through the focal point like they do with a concave mirror. They actually diverge. Diverging objects have virtual focal points. So therefore, it's got a virtual focal length. So when we're setting it up with our equation, we're going to say that F is negative 3.0 meters. So we have to know that. We have to know that for a convex mirror, it's a virtual focal point. Now, in the previous question, I quickly ran through the vectors and we can see roughly what happens. Any vector that starts off parallel, when it strikes the mirror, it will diverge, but it'll diverge specifically so that this diverging ray is exactly in line with that focal point. So this is one of the reflected rays. The second reflected ray, if I start a ray directly aimed at that focal point, so if I continue this line, it ends up passing through the focal point. Right when it hits the mirror, it ends up coming flat. And those two rays have to cross. Those two reflected rays have to cross. And you can see on the left, they don't cross, but they appear to converge right here where I've drawn the image. So we're going to try and figure out now what DI is using the lens maker's equation. DO is 4 meters. So here's our given information. DO is 4 meters. DI is unknown. So when I do my equation, 1 over F, 1 over DO plus 1 over DI, I get 1 over DI is 1 over F minus 1 over DO. And then when I put in my numbers, I get 1 over negative 3 minus 1 over 4. Now remember, you have to put that negative in there. And when I crank that out, I get negative 0.583 repeating. But that's not my answer. That's 1 over my answer. I have to flip this one more time. I have to figure out what 1 over that is. And remember, I'm using that x to the minus 1 button on my calculator. Just makes life a lot easier. So I end up getting an exact value for my image distance to be negative 1.71. Now the negative means virtual with this equation. So the rays aren't actually there. They are only appearing to originate from there. So I got a virtual upright image. Now let's get our height. So I know magnification, negative HI over HO. Sorry, it's not negative, my mistake. Magnification is HI over HO, which is negative DI over DO. And let's solve this for HI. Like that. And when I put in my numbers, I get negative of negative 1.71. That was DI. All over DO, which was 4.0. All multiplied by HO, which was 12 centimeters originally. Now notice my meters cancel and I'm left with centimeters in my answer. So when I finish the math on this one, I end up getting 5.14. And it's a positive number. Positive in this equation means upright.